So equation of the circumcircle of the triangle ABC whose vertices are given. First method. So if I consider the circumcenter S as x comma y because it is equidistant from the three vertices, so use SA equal to SB and SB equal to SA, then you will get two equations in terms of x and y and solve to get the circumcenter, and SA or SB or SC is the radius, then you can write the equation of the circle. Second method. Circumcenter is the point of intersection of perpendicular bisectors of any two sides of the triangle. Now, after getting the circumcenter, take either SC or SB or SC as a radius and write the equation of the circle. Third method. Use the general form of the circle x square plus y square plus 2gx plus 2fy plus c equal to 0 and substitute the vertices a comma b and c to find the constant g, f and c by solving the system of equations. So the 4 points a comma b comma c and d are said to be concyclic if they lie on the same circle. So to prove any 4 points are concyclic, take any 3 points and calculate the equation of this circle using any of the above method and substitute the fourth point. If it satisfies, then we can conclude that they are concyclic. Otherwise, they are not concyclic. So equation of the circumcircle of the triangle ABC whose equations of sides are given. So let us consider the triangle ABC whose sides are L1, L2 and L3 equal to 0. So the first method is solve for the vertices by solving the system of equations and then use one of the previous methods. The second method is when I consider the joint equation of any two lines, it becomes a second degree equation. But instead of taking only one pair of equations, let us take a combination. So the second degree equation formed by L1 L2 plus lambda times L2 L3 plus mu times L3 L1 equal to 0. This will be a second degree equation, and this equation will be satisfied by all the three vertices a comma b and c. So this represents a circle only when coefficient of x square must be equal to coefficient of y square and coefficient of xy must be equal to 0. So by solving the equations, then we can get lambda and mu. After that, you back substitute it, then to get the equation of the circumcircle.
Sir.
So equation of the circumcircle of the quadrilateral ABCD whose equations of sides are given. That is L1, A1x plus B1y plus C1 equal 0, L2, A2x plus B2y plus C2 equal 0, L3, A3x plus B3y plus C3 equal 0, L4, A4x plus B4y plus C4 equal 0 in the same order. That if I take a quadrilateral ABCD and if I take L1 equal to 0 represent the side AB, then I should take L2 for BC, L3 for CD and L4 for AD. That is one specific order only we have to follow. That is the meaning of same order. Now the first method to find the circumcircle is solve for the vertices A, B, C and D and use any 3 points to find the equation of the circle and verify the fourth point. If it satisfies, then the circumcircle exists. Otherwise, you cannot have a circumcircle. The second method is forming a second degree equation. That is by taking the combinations L1, L3 plus lambda times L2, L4 equal to 0. So this will be a sum core of second degree. So this will represent a circle only when coefficient of x square equal to coefficient of y square and coefficient of xy equal to 0. So here you are having two conditions, but you need to calculate only one parameter lambda. So you solve any one condition and verify the another condition. If it satisfies, then this curve will represent a circle. Otherwise, this curve will not represent a circle. So maximum and minimum distance of a point with respect to a circle. So let us consider S equal to 0 is the circle equation is given. Once the circle equation is given, you can calculate the coordinates of the center and radius. And px1 comma y1 is a point also given. Now we can decide the position of the point with respect to the circle by calculating s1. If s1 is greater than 0, we can say that the point is outside the circle. If s1 is 0, then we can say the point is on the circle. If s1 is less than 0, we can conclude that the point is inside the circle. So let us consider the case when the point is outside the circle. So you join the given point with the center and produce it to intersect the circle at A and B. Then the maximum distance of the point P becomes PB length, so which is distance between the given point and the center plus the radius. Now minimum distance will be PA, which is again distance between the given point and the center minus radius. Suppose if I want to calculate the vertices, vertex A and B also, A divides the line segment joining PC internally in the ratio of PA to AC, whereas B divides PC externally in the ratio of PB to BC. So intersection of a line and a circle. So there will be three cases. One case is the line can intersect the circle in two distinct points, or the line touch the circle, or the line may not intersect the circle. So how to find the condition when a line intersects the circle in two distinct points, one point and no point, when circle equation is given and a line equation is given. So let us determine the conditions for the line y equal mx plus c to intersect the circle in two distinct points, two coincident points and no point. Also find the length of intercept on the line made by the circle. So we'll do two methods here. So one method is a general method which is applicable not only for a circle, for any curve also. After that we'll do the one more method which is applicable only for the circle. So to determine the conditions, substitute y equal to mx plus c in the equation of the circle and expand and simplify. Then we get a quadratic in x. Since x is a real, so we can calculate the discriminant, which is 4 into a square into 1 plus m square minus c square. So if the discriminant is greater than 0, then that becomes the condition for the line to intersect the circle in two distinct points. That is, if a square into 1 plus m square is greater than c square, then we can conclude that the line intersects the circle in two distinct points. If c square equal to a square into 1 plus m square, then we can conclude that the line touches the circle, which is the condition of tangency. If a square into 1 plus m square is less than c square, then we can conclude that the line do not intersect the circle. Now we need to find the length of intercept also. So to find the length of intercept AB, let us consider A x1 y1 and B x2 y2, which satisfy the circle equation as well as the line y equal mx plus c. Also x1 and x2 are the roots of this quadratic equation in x. Then we know what is the sum of the roots and product of the roots, and use the distance between the 2 points formula and use all these conditions to find the length of intercept. So A x1 y1 and B x2 y2, because it satisfies the equation y1 equal to mx1 plus c and y2 equal to mx2 plus c. So from this we can calculate y1 minus y2, and x1 minus x2 we can calculate from the quadratic equation, because we know sum of the roots and product of the roots. So distance between the 2 points will become AB equal to modulus of x1 minus x2 into root of 1 plus m square. So after calculation of x1 minus x2 is substituted here. So the length of intercept on the line y equal to mx plus c made by the circle x square plus y square equal to a square is 2 into root of a square into 1 plus m square minus c square upon root of 1 plus m square. Now using this length of intercept also, we can write the conditions for two distinct points, two coincident points and no point. Because two distinct points means this must be greater than 0. When this is greater than 0 means a square into 1 plus m square minus c square must be greater than 0, which is the same condition what you got before. Next, two coincident points means this length of intercept must be 0. So a square into 1 plus m square minus c square must be equal to 0. And no point means this inside portion must be less than 0. That is a square into 1 plus m square minus c square is less than 0.
Excuse me, sir.
So the second method is, so because we know the circle equation x square plus y square equal to a square, so center is 0, 0 and radius is a. Now, if this line intersects the circle in two distinct points, then the perpendicular distance from the center to the line must be less than the radius. That is, perpendicular distance must be less than the radius. That is, the length of CD must be less than A. So, perpendicular distance from origin to the line is modulus of C upon root of 1 plus M square less than A. So, square it and cross multiply. So, C square is less than A square into 1 plus M square. So, which is the condition for the line to intersect the circle in two distinct points. Now, for coincident points means the perpendicular distance must be equal to the radius. That is, condition of tangency is C square equal A square into 1 plus M square. Next, when the line do not intersect the circle is possible only when perpendicular distance from the center to the line must be greater than the radius. That is, C square is greater than A square into 1 plus M square.